Welcome back to Vuln Vibes. In this deep dive, we are going to talk about a particularly nasty .NET vulnerability, one that should probably be right at the top of your patching schedule right now.
Yeah, we're zeroing in on a critical, really severe flaw affecting ASP.NET Core's own web server, Kestrel. Our mission today, move past the headlines, really execute a full technical deep dive on CVE 2025-55315. This isn't just, reading an advisory. We need to dissect the specifics, the smuggling mechanic, understand why it scored that critical 9.9 CVSS, and maybe most importantly, detail the multi-layer defense strategies you need. This is, well, it's an immediate protocol integrity audit challenge for every security pro listening.
That framing is spot on because for our audience, seasoned IT security folks, the core concept here isn't some simple buffer overflow or something. No, this is classic. It's an architectural vulnerability, a fundamental failure of consistent HTTP parsing right at the network edge. And that almost inevitably leads to request smuggling. When we talk request smuggling, we mean bypassing pretty much every security control sitting upstream of that vulnerable endpoint. Okay, right. Let's unpack this then. The identifier, CVE 2025-55315. We know it's critical. HTTP request smuggling inherent in ASP.NET Core. And Kestrel is the target here. That's significant, right? Because it's the default, it's the high-performance server in modern, often containerized .NET apps.
Exactly. And the underlying mechanism is, well, it's instructive, and frankly, it keeps popping up in our industry. We classify this as CWE 444, inconsistent interpretation of HTTP requests. Think of it like a security checkpoint. The guard at the front gate and the guard inside the building. They have slightly different rule books. The flaw happens when different components, your front-end load balancers, proxies, maybe an API gateway, interpret a specially crafted, ambiguous HTTP request differently than the Kestrel backend does.
Oh, okay. So maybe the proxy is a bit lenient, sees one request, passes it along. But then Kestrel, maybe being a bit stricter or just different in its parsing logic, suddenly sees two requests.
That's exactly it. The first request, often harmless, maybe just a wrapper, gets processed, logged normally. Everything looks fine. But Kestrel messes up finding the end of that first request. It then starts processing what it thinks is the body, but it's actually leftover bytes, which contain the smuggled second request, the malicious one. And the second request completely bypasses all the upstream security, all the logging, gone.
Wow. That dual interpretation, that's the whole game right there. So when we look at the severity, that CVSS 3.1 score of 9.9, I mean, that's terrifyingly high. Let's break that down. What pushes it right up to critical?
Well, the 9.9 is definitely justified. Three key things, really. First, attack vector.network. You can hit this remotely, no physical access needed. Second, attack complexity. Low. This tells us it's relatively easy to exploit, probably using, known header manipulation tricks, not exotic. And finally, integrity and confidentiality impacts are both high. A successful smuggling attack basically gives the attacker near total control over what happens next in the request pipeline. And crucially, zero user interaction needed, low privileges required to launch it. So once an attacker figures out the specific parsing quirk for a given proxy and Kestrel combination, they can weaponize this almost instantly.
Right. Which makes it incredibly accessible for automated scanners and opportunistic attackers. Scary stuff.
Yeah.
Now let's talk payload. Once that second smuggled request slips through, what are the main goals? What are the catastrophic results we're looking at here based on the source material?
Well, what's fascinating, and maybe a bit scary, is the sheer range of high-impact scenarios. The simplest, maybe the most dangerous goal. Bypassing authentication or authorization checks? Straight up. A successful smuggler can craft a request aimed at a private internal endpoint. And because Kestrel processes it internally, it might look like it came from a trusted source, like the proxy itself. Boom, unauthorized access.
So we're talking attackers hitting internal endpoints that should be firewalled off, viewing sensitive data, or even manipulating sessions to act as another legitimate user.
Yes, exactly. Total session compromise is definitely on the table.
Okay, and connecting this to the bigger picture, modern architectures are complex.
They really are. And the risk escalates there. These environments often rely heavily on request headers for making critical decisions. So in specific setups, a smuggling attack could be leveraged to forge server-side request forgery SSRF requests. That means forcing the backend server to talk to internal resources it shouldn't be talking to externally. Think metadata services, internal databases, and maybe even more concerning, especially for cloud operators, if you're running a multi-tenant solution where logical separation is handled by an upstream gateway. A successful smuggling attack could potentially break that separation, facilitate unauthorized cross-tenant data access. That's massive data breach territory.
Oof. Yeah, that's the nightmare scenario, isn't it? A fundamental protocol flaw, just demolishing architectural segregation. Okay, shifting gears slightly. For the security teams listening, doing rapid asset management, vulnerability scanning, the scope is critical. Let's quickly list the affected versions so people know exactly what to hunt for in their environments. All right, so the specific affected ASP.NET Core versions, stripped from the advisory, 8.0 running up through 8.0.10, 9.0 through 9.0.9. The 10.0 pre-release builds up to version 10.0.0-RDs.1.25451.107. And we can't forget legacy systems. ASP.NET Core 2.3 is also implicated, specifically via Microsoft.ASP.NET Core.Server.Core versions 2.3.0 and older.
Right, the list itself is straightforward, but the operational complexity, that often lies in deployment strategies, particularly containerized applications. This is where we see orgs trip up on patching audits again and again. If your organization uses immutable infrastructure, relies heavily on container registries, just applying an OS patch or updating a NuGet package in your build pipeline, that might not be enough. You absolutely must rebuild your base container images using the updated runtimes. Why? Because old, vulnerable Kestrel code often persists deep down in an image layer somewhere. It gets executed when the container spins up, even if you thought you patched higher up. So security teams really need to ensure their CI/CD pipelines are enforcing the use of the new patched base images, like 8.0.21 or 9.0.10 and newer.
That's a really crucial operational point. It's not just a hotfix. It often forces a full image rebuild cycle. Okay, let's move to the crucial phase, defense in depth, mitigation steps, because just relying on the patch might still leave gaps if the network configuration itself remains ambiguous.
Absolutely. We can't only rely on the application layer patch. History shows these kinds of flaws, these parsing inconsistencies, they tend to resurface, especially with complex proxy interactions. I mean, just look back at the high-profile smuggling attacks over the last, say, decade. Whether it's against CDNs or internal proxies, the ambiguity baked into HTTP 1.1 headers is just this constant source of grief for defenders.
That's a great point. It's a cyclical vulnerability class. So what's the best strategy then, starting at the network edge?
First and foremost, header rejection and hardening. Get tough on ambiguous headers. Organizations absolutely must configure all their upstream proxies, CDNs, load balancers, whatever's in front of Kestrel, to proactively reject ambiguous HTTP headers. The number one signature you have to block. The dual use of transfer encoding, usually TE chunked and content length CL headers in the same request. Seeing both in one request is a textbook smuggling attempt. It's explicitly designed to confuse components that might prioritize one header over the other.
Right, that dual header ambiguity.
Yeah.
It's like a flashing neon sign saying attack in a way. If you don't explicitly need both for some reason, just reject requests that have both.
Exactly. Reject outright. Secondly, and this is more strategic, absolute parsing normalization. This is the core defense against CVE 444 itself. You have to audit and enforce that the HTTP request parser logic is functionally identical across the stack. Specifically, how headers are handled, how white space is treated, how the request body length is calculated. All of it needs to match between your front-end proxy layer and your back-end Kestrel instance. So if you use NGINX or HeyProxy or maybe a cloud provider's load balancer, you need confirmation or testing to ensure their parsing behavior lines up with the patched Kestrel runtime. Eliminate the inconsistency.
Okay, that makes sense. And operationally, we need to find the attackers who might be probing for this right now. What should security teams be hunting for in their SIEM, in their logs?
Yeah. Proactive log monitoring is mandatory here. Don't just wait for a breach alert. Look for the probes, the failed attempts. You should be flagging and alerting on any logs showing unusual pipeline requests, or any structurally malformed HTTP requests that trigger weird, non-standard error codes from either the proxy or Kestrel. More granularly, look for request logs where the request length calculated by the proxy may be logged in an internal forwarding header doesn't match the content length reported downstream in the Kestrel logs, or situations where headers like X forwarded for suddenly appear multiple times in inconsistent ways. These discrepancies scream smuggling attempt.
Good indicators. Okay, finally, even if we patch Kestrel, we tune the proxies. What about the internal application logic itself? Could that still be vulnerable?
That's the last piece. A logic review is essential, because even a single temporary successful smuggling attempt might have already exploited a weak point in how your application handles things like session IDs or internal redirects. Security teams need to audit their existing authentication and session handling logic. Assume breach, in a sense. Identify and close any possible bypass paths. For instance, are you implicitly trusting a local internal header to confirm authentication? An attacker might be able to overwrite that via a successful smuggle. You have to assume that internal request channel could have been polluted at some point.
That really brings us back full circle. This CVE 2025-55315, it serves as a potent real-world reminder of how subtle differences in handling fundamental protocols, specifically HTTP parsing inconsistency, how they can cascade into really severe, remotely exploitable security breaches. Critical impact scores, the works. So immediate patching of affected .NET runtimes, absolutely necessary. But it must be paired with rigorous granular auditing of your network edge configurations.
And that raises, I think, an important final question for you, the listener, to explore back in your own operational planning. Given the complexity of modern microservice architectures, often using multiple layers of proxies, API gateways, load balancers, maybe all running different software, what specific operational hurdles does your security team face in trying to enforce absolute HTTP parsing normalization across all those different, potentially heterogeneous components? Because that fundamental distributed consistency challenge, that's really the ultimate difficulty in perimeter defense today.
Absolutely. Security really is about consistent interpretation, isn't it, across every single layer of the stack. And this CVE proves, quite painfully, the cost of inconsistency. So for all our professional listeners, please immediately verify your deployment status against that affected version list we mentioned and start that parser normalization audit. It's critical. Until next time, stay vigilant and stay patched.